The widespread adoption of artificial sweeteners as supposedly healthier alternatives to sugar has created a massive natural experiment, and emerging data suggests the results may be considerably less reassuring than industry marketing implies. Recent long-term cohort studies examining cognitive outcomes in artificial sweetener consumers reveal signals that demand attention, though the evidence remains mixed and interpretation requires nuance. The most concerning findings emerge from large-scale prospective cohorts tracking participants for 8 or more years. Brazilian researchers following nearly 10,000 adults documented associations between regular artificial sweetener consumption and accelerated decline in verbal fluency and memory test performance, with effects particularly pronounced in individuals consuming diet beverages daily. Similar patterns appear in North American cohorts, where habitual diet soda consumption correlates with elevated stroke and dementia incidence even after controlling for diabetes, obesity, and cardiovascular risk factors. The biological plausibility of these associations remains contested. Some mechanistic studies suggest certain artificial sweeteners, particularly aspartame and sucralose, may influence gut microbiome composition in ways that affect systemic inflammation and glucose metabolism. Other research indicates potential direct effects on neuronal function, though these findings come primarily from animal models using doses exceeding typical human exposure levels. The sugar alcohol erythritol has garnered particular scrutiny following studies linking it to cardiovascular events, raising questions about its broader metabolic effects. However, interpreting this evidence requires acknowledging substantial limitations. Observational studies cannot definitively establish causation, and residual confounding remains a persistent concern. Individuals who consume artificial sweeteners typically do so because they already face metabolic or weight challenges, creating what epidemiologists call confounding by indication. Even sophisticated statistical adjustments may not fully account for these underlying health differences. Additionally, some studies show null findings with no cognitive differences between artificial sweetener consumers and non-consumers. Regulatory bodies, including the FDA and EFSA, maintain that approved artificial sweeteners are safe at typical consumption levels, pointing to extensive toxicology studies and decades of widespread use without obvious population-level harm. These agencies periodically review emerging evidence, but have not substantially revised safety determinations based on recent cognitive studies, arguing that the observational nature of the data precludes definitive conclusions. The prudent interpretation acknowledges uncertainty while recognizing reasons for caution. The absence of definitive proof of harm differs meaningfully from proof of safety, particularly for exposures affecting the developing brain or consumed over decades. For individuals seeking to reduce sugar intake, artificial sweeteners represent one option among several, but they should not be considered a consequence-free solution. Warning: the most conservative approach involves treating artificial sweeteners as a transitional tool rather than permanent dietary fixture. Gradually retraining taste preferences toward less sweet beverages altogether offers advantages over perpetually seeking sweet-tasting alternatives, whether caloric or not. Water, unsweetened tea, and coffee provide hydration without metabolic concerns. For those who continue using artificial sweeteners, limiting consumption to occasional rather than daily use and diversifying sweetener types rather than relying exclusively on one compound may reduce any potential cumulative effects. Parents should be particularly cautious about habitual artificial sweetener exposure in children, whose developing systems may prove more vulnerable to subtle metabolic or neurological effects.